Okay, so good morning. Today we are going to look at uh, object-oriented databases. Okay, so when we think of databases, we are familiar with relational databases, right? So why do we need object-oriented databases? So generally, object-oriented databases are used when we want to store complex information. Say, for example, when we want to store say a CAD design, which is a really complex object, right? So when we think of designs in relational database, we know that a single object is actually spread over multiple tables. That is how we go for design of relational database, right? But in the case of object-oriented database, it is possible to store data of any level of complexity that can be stored in an object-oriented database. So that is the advantage of having object-oriented databases. Okay, or that is a need for object-oriented databases. Okay, object-oriented concepts. We are all familiar with the different object-oriented concepts. We have already learned in BTech also about object orientation. So there is everything is represented in terms of an object, right? Any data is represented in terms of an object, and it has two components. One is a state, so or the attributes of that particular object, and then the behavior is also defined. So we have state as well as behavior. That is what makes up an object, and it is of a very complex type. Then Okay, in object-oriented programming, when we talk about objects, those objects are actually transient. Transient means they exist only during the execution time of the program. But in the case of databases, we know databases means you're storing the data and we want the objects to be persistent. Okay, objects have to be persistent. Okay, or it has to be saved across multiple sessions and multiple systems. So one system should be able to write an object to the database, and another should be able to retrieve and so on. So it has to be persistent. But that is a difference from normal object orientation concepts. Then of course we have the concept of object instance, which holds the value that defines the internal state of an object. We have encapsulation. Encapsulation means that is you're combining the uh, the state as well as operations are combined together. That is what you're encapsulating all of them into a single object, right? Then there is a concept of inheritance and operator overloading, function overloading. All these are normal object-oriented concepts. But in the case of object databases, how it is different is we have to ensure persistence of objects across multiple sessions and multiple systems. Okay. And another fact is the concept of an object identity. Okay, so in object databases, every object or every class has an associated identity, and that is a unique identity which is system generated, and that is represented using an object identifier, a number, a unique number. Generally, when we talk about relational databases, we talk about keys. Okay, key actually is an attribute which is present in the table itself, which is unique and which can uniquely identify a tuple, let us say. But in the case of an object identifier, it has a uniqueness, but it is a system generated number, and it is not part of the value stored. Okay, it is a system generated number. So that is used to identify every object. And this OID, it is not visible for the external user, but it is internally used by the system to identify the object. And this OID is immutable or it cannot be changed. Okay. Uh, Okay, there is also, so objects are identified using what are known as OIDs, and there is also a concept of literals or values. But literals എന്ന് പറഞ്ഞാൽ it is just a value associated with some attribute. Okay, and no OID is literal has no OID associated with it. So literal value is stored within an object, but it cannot be referenced from other objects because no OID is associated with it. Okay, so in case of objects, there is an OID associated with it, which is system generated. It is unique, but it is not part of the uh, what the values or the attributes stored as part of the user requirements. It is a system generated value. Okay. 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 So we said object oriented databases are used for storing complex uh, data types or complex data structures. So what are the basic building blocks of those complex data structures? That is what here we have discussed. Okay, so in object databases, objects can have type structure of arbitrary complexity. Any level of complexity can be stored using objects. And but in traditional data, all information about the object is contained within an object in the case of object databases. But in traditional RDBMS, the information about an object is scattered across multiple tables, which we already said. So, so if it is of complex or if it can store, if the object can store data of arbitrary complexity, what are the building blocks which make up that object? So one is atomic constructor or atomic data type. Atomic data type means generally when we talk about atomic, which it cannot be split any further. So atomic data types in the case of object databases are integer strings, floating point numbers, enumerator data types, booleans. All these form the basic atomic constructor. Then we have the concept of a struct or a tuple constructor. Tuple, it is similar to the struct in C or it is similar to a tuple in Python also. So generally we write in bracket label. Okay, within bracket we write the value of say for example, I think we have an example here also. Okay, here we have got date. Date type is made up of a tuple which consists of the year, month and day. It together form a single unit, right? And it is made up of year, month and day. It is represented in a single bracket. So that makes up a tuple. Okay, that is what a tuple consists. That is another basic type. Then we have the concept of a collection. Okay, a collection means it is a collection or set of values. Okay, so different types of sets are there. One is a set, one is a list, then bag, array, dictionary. All these are used to make up the complex data type. And when you talk of set, what is a set? Set means നമ്മൾ മാത്സിൽ പഠിക്കുന്ന സെയിം സെറ്റ് കോൺസെപ്റ്റ് ആണ്. So objects or literals that are a set of distinct elements, say for example like this, they are all of the same type, and the important thing here is they're distinct elements. When you put, that is a concept of set, right? When we put certain elements into a set, all of them are distinct. That is what is important. But in the case of a bag or a multi-set, it is actually similar to a set, but the elements need not be distinct. You can have duplicate elements. Okay, now list. List is another constructor which is similar to a set, but it is ordered. There is an order associated with values in the list. Then of course you have the concept of an array constructor. So it is a single dimensional array which we are all familiar with and is similar to a list, but it has a maximum size associated with it, which is not there in the other cases. Then of course dictionary constructor. Those of you who are familiar with Python will know the dictionary constructor. This dictionary consists of a set of key value pairs. So you give the key and you get a value as the output. So it's something like a hash table. That is a dictionary concept. So these are the basic building blocks or type structures for building our objects. Okay. Okay, this is an example. Here, look, employee type is there. Its basic attributes are there. Now, this is actually a reference. Supervisor is also another employee. And this similarly department of this particular employee is another object. And this object is identified using the OID of the department object. Okay, Similarly, if you look at this, we have sets, a collection of, that is the department can have multiple locations. So not a single string is required, multiple values are required, right? So that is why it is represented using a set. In similarly, department can have multiple employees as well as multiple projects, which are also represented using sets. Okay, encapsulation. Mm. Okay, encapsulation. We are all familiar with encapsulation. That is a basic building block of object-oriented programming, right? Encapsulation is basically you're combining the data part as well as the operation part into a single unit. And if you want to access the data part, it is always through the interfaces provided by the operations. Okay, so that gives protection to the data present. Okay, so here, in the case of traditional databases, all operations can be applied on all data, right? Any user can write a query to access any data. But in the case of object-oriented databases, we have the concept of encapsulation, which means if you want to access some data, any sort of access to data present within an object is only possible through the operations defined for that object. അപ്പോൾ എല്ലാ ഓപ്പറേഷൻസും ഒന്നും നമുക്ക് ചെയ്യാൻ പറ്റില്ല. ഇറ്റ്സ് ഓൺലി ദോസ് ഡിഫൈൻഡ് ബൈ ദോസ് ഓപ്പറേഷൻസ്, ഓൺലി ദോസ് ക്യാൻ ബി ഡൺ, വിച്ച് മീൻസ് യു ഹാവ് അറിയാതെ നമ്മൾ ചില ഓപ്പറേഷൻസ് ചെയ്ത് എറേഴ്സ് സംഭവിച്ചേക്കാം. ദാറ്റ് വിൽ നോട്ട് ഹാപ്പൻ. ദാറ്റ് ഈസ് എ ബേസിക് കോൺസെപ്റ്റ്. ഒബ്ജക്റ്റ് ഓറിയന്റേഷനിലുള്ള കോൺസെപ്റ്റ് തന്നെയാണ്. ദാറ്റ് ഈസ് അഗൈൻ എംഫസൈസ്ഡ് ഹിയർ. Okay, here we had seen earlier an example of employee as well as associated types and all that. But here you also have, look, operations are also defined. What is the age of the employee, create an employee, destroy an employee. All these operations are also defined in this case. Okay, so that is also shown here. Now, this is an important concept in object orientation, right? Object persistence. So how do we provide, how is persistence possible? So there should be some mechanism for providing persistence, and two mechanisms of persistence are provided by object databases. One is naming and the other is reachability. And naming means you are giving a persistent name to an object. Okay, so if there is an employee object, there is a name, a persistent name associated with that employee object, which you can use to access it. But you can have so many thousands of objects which are created in an application. So accessing them or calling them through name is not a feasible option. So that is why we have another option called reachability. And for reachability mechanism, what is done is make the object reachable from some other persistent object. So generally what is done is we create a persistent object which is basically a collection. Collection we already talked about is a set, is a collection of objects. So the name, the reachability is through the name of the collection, and inside the collection we have all the persistent objects which we need to access. Okay, so that is how persistence is achieved. Generally this sort of persistence is what is being used. Okay, so how is reachability achieved? First, create a named persistent object n whose state is a set of objects of some class C. Okay, so n is the persistent object which is created, and it is generally a collection of objects, and it is objects of type C that which we need to access. So C can be made persistent by adding objects of C to the set n, thus making them reachable through n. Okay, so that is how it is, and is the concept is generally called extent, which we will see later. Okay, so object persistence can be done through two mechanisms. One is through persistent naming of objects, but that might not be feasible when we have lots of objects which we need to access. So in that case, another concept called reachability is used. In reachability, what we do is we create one single name persistent object, which is generally a collection, and into the collection we add all objects which we need to access. Okay, so that is the mechanism used. Okay, say for example we have a department is a type. Okay, department has several attributes as well as several operations associated with it. And so we say persistent name all departments. So all departments is the actual the persistent object we talked about, and into this we add a different uh, objects of departments. So through this particular all departments we can access. So all departments is actually the collection we talked about, and within the collection we have several persistent objects. Okay. Okay, inheritance is an object-oriented concept. Inheritance is also supported by uh, object databases. So, say for example, employee is a subtype person, or manager is, these are under employee type. So, the different mechanisms through which we can have inheritance. So, we look at examples later. So, inheritance is actually supported in object databases. Okay, polymorphism, operator overloading, all these are supported, but multiple inheritance is generally not supported by object database.